Welcome back. I hope you still remember before we have introduced this tuple-based checks, attribute-based checks, as well as assertions, right? We have mentioned they are working on different levels. The attribute-based checks, they are working on some specific attributes, and tuple-based checks are working on a specific relation or table, right? And this assertion is working on for all the tables inside database systems. It's at a higher level. We already mentioned before that the checks, the assertions may have some shortcomings, especially when we have some modifications in a large size database systems, and minor changes to or modification to some relations may always check these kinds of assertions. Therefore, we need to have some other tools to help us, which is called triggers, as shown here. Before we talk about triggers, I'd like to provide the motivations why the trigger is necessary and important. Before we mention its attribute and tuple-based checks have some limited capacity, and its assertions are sufficiently general for most of the constraint applications, but they're very hard to implement efficiently. A minor modification will check all the assertions inside database systems. It's very costly. And database system must have some real intelligence to avoid checking assertion that couldn't possibly have been violated. Before we show some examples, right? If we make some changes to some other uncorrelated tables, then this assertion will not be violated, right, by default. However, according to the definition of assertion, we still have to check the assertions, no matter which table we are making, to make changes to. In other words, this assertion lacks this intelligence in checking some conditions, right? So the solution we can have is called trigger. A trigger allows the user to specify when a check occurs. And like an assertion, a trigger has general purpose conditions and also can perform any sequence of SQL database modifications as the action or the response. The trigger will be much more powerful and also helpful for us. The trigger is based on the ECA, this rule. ECA means event, condition, and action rules. It is also another name for trigger is called ECA rule or event, condition, action rule. So when an event occurs, and based on some conditions, we will take some actions. So this is what the trigger will do actually. So what is the event? Event denotes a database modification that inserts on some tables. Once an event happens, we need to check some condition, right? Because some of this event, like insertion, may cause some condition to be true, because some other event may cause this condition to be false. We have some condition to prove this event to help us. So the condition can be any SQL Boolean expressions. Based on an event, we define some conditions. If the condition is true, then we will move to the actions. Action will be some SQL statements. Once the event happens, we check if the condition is true or not. If true, we will take some actions. This is what the trigger will do, actually. We'll provide you with an example that instead of using the foreign key constraint and rejecting the insertion into the sales table with unknown beers, a trigger can actually add a beer to the beers table with a null manufacturer. Before we mentioned that with a foreign key, if we make some changes like insert some of the serial records into the sales table, according to the previous knowledge, we mentioned that the foreign key will reject this insertion if this beer is unknown, right? It may also make some problems, right? Because if we insert an unknown beer to the sales table, another way we can do is to add this unknown beer to the beers table. It will make this constraint and the foreign constraint to be valid, right? If we want to achieve this kind of purpose, then we can use a trigger. If we insert into a sales table with an unknown beer, actually we can define a trigger. We can add this beer to the beers table. Because we know the beer name, right? But right now we don't know the beer's manufacturer. Then we can add the null manufacturer to the table instead. So this is a trigger we can define for this kind of insertion into a sales table, right? Then how can we define its trigger? we can provide the definition of a trigger as shown here. We can create a trigger with a trigger name, be a trigger. It's a name you can define with any name here. And inside the trigger, we have the event, condition, and action. The event we have here is after insert on sales, because we will insert some new tuples into the sales table, right? Here we use this after denoting this timing of this action or this event after we do the insert into the sales table. And here we have two more rows. We can just go to the next row instead, where this new tuple .beer not in select name from beers. This new tuple denoting the new data we are adding into the sales table. New tuple.beer means the beer of this new data record is not in the beers table right now. It's a condition, right? If this condition is true, we'll do the action. The action we have here is insert into beers with name, right? Value new tuple.beer. Because right now we only know the beer name, right? We can insert this value into the beers table. And we specify the attribute corresponding to this data we have here is a name for the beer, right? Right now we don't know the manufacturer. Therefore the manufacturer will be null by default. So this is a condition, this is an action, this is an event. Here we have this after, when. These are the keywords we use to define the trigger. And between them we have two more rows, referencing new row and new tuple. This new row denoting the new data we are inserted into a sales table, and reference this new row as a name is new tuple. Therefore, inside the condition, we can use new tuple reference to this new row, right? We are inserted into a sales table. We can also refer to its attribute, the new tuple.beer. Another row we have here is called for each row. For each row means for each tuple we are inserting here. I hope you can follow me, right? So in this way, we can define a trigger when we insert some new tuples to a sales table, and we can get the new data we are inserting with this line, referencing new row as a new tuple. And for each of these new rows, we check this condition. When we have the subquery, we have branches, this new data, new tuple.beer, its beer name is not in the beers table right now. It's a new beer or unknown beer. The action we can take is to insert this unknown beer into the beers table. We can insert into beers table, specify its attribute is a name for the values for the string. We have values, new tuple.beer, it's a name for this unknown beer. We can insert them into the beers table. In this way, we can make sure the new tuples we have in the sales table refers to a valid and existing beer in the beers table, right? So it's a trigger, and all the rows in this trigger can be divided and introduced in details in the following pages. I hope right now you can follow me this definition. You can do the high-level idea of the trigger, right? And then let's go deeper into the details of this trigger.